Hi. So we'll continue our exploration into generating the AI videos. Today we are in live stream number 8, and we were almost done with generating the final files that we will be using to generate the final video. And there's just one frame that I want to generate now. So without further delay, let's get started. I'll be back soon. Hey, I'm back now. So without further delay, let's get started on generating the final frame. All right. Okay. I think my video is frozen. Just give me a moment. There is a problem. Just give me a second. I'll fix it. Okay. I have fixed it in one stream. Just going to fix it in another one. All right. Okay. So now we will jump into our favorite tool that we have been using so far. That is Collab. So we'll go to Collab. So in case if you are wondering, Collab is a way for us to run the LLMs because they provide GPU, large GPU instances on demand. Now you can always use anything else. Like if you have local GPUs, you can try it. But generally, the models that we are working with are pretty large. So you would need like a good GPU, good local GPU. And I don't know if people are carrying like that much big GPUs. So Collab is very practical way for us to work with these kind of projects, wherein you can take a big model, run it, and in couple of hours you have whatever you want, and the cost is kind of not very high if you're just dealing with like few hours, rather than if you have to buy a GPU, then the cost will be high and the usage has to justify the cost, right? So that's why we have to be careful, and Collab is a very practical way of working with these kind of models. Anyways, let's get started. uh, I'll just connect to a high GPU instance now again, and drop me a message or whatever if you feel, if you have any question on whatever I'm doing. I'll be more than happy to answer. Okay, so GPU is on. We'll connect to this. We'll just start doing some things. Meanwhile, we'll just copy the local model. You have to go to downloads, to the training, samples, models, videos. No, we have to use story. We have to use our model. This model is fully trained, and if you don't know, I think it was stream number 5 wherein we created this model, and this model is very important to generate your faces to whatever you want, right? So for example, if this model is trained on me, so that's why it's able to generate my faces, but you can always train it to your actor, yourself, or whatever you want in the game, in the video, and this model will do it. So very interesting in that regard. Now we are just let's download this also while this file is getting uploaded. So it's going to take fair bit of time because this model I think is 190 MB or something, 172 MB. So meanwhile, the base model of Flux is going to take some time. So what we are doing here is we'll be using this Flux to generate lots of these models, and yeah, so we will get started. So meanwhile, I'll just share whatever we have generated for this storyline. So we have started with this first scene, which will be animating in shortly after we are done generating these. Then we have, I think, some more. This is the scene number 2. Actually, after some time, we realized that we need like this aspect ratio for good videos. But okay, then we have got 3, which is coding 1, and then we got 4. The bug fixes. Number 5 I want to do is like a celebration thing, and then we are done with the image generation. So let's create a folder called LoRa, and these models are called LoRa models, and we'll drop it there. Now this base model is ready. Let's move it to GPU. So you'll see the GPU usage will go high. All right. So this is ready. Let's continue this. So now we can set up the LoRa model first. So I should probably fix the order of the commands in this system. So anyways, the model is loaded, and for some reason, even if I, so usually from what I know, we have to pass this into the text somewhere, like the activation thing, but it's not really needed because the moment I was earlier generating something anyways, it was always generating my face. So maybe if you have one LoRa, somehow the system will always use that LoRa. But let's continue. So yeah, the last prompt is man celebrating uh, in a meeting room. Just let's see where this image takes us, and then we can, of course, change the prompt and do something else. All right, it's almost done. I also want to explore Comfy UI in the next stream, but let's see. I mean, like I'm more comfortable with code because I can see all the parameters and things like those. This is fine. When celebrating in a meeting room, let's do another one. Maybe change the seat to 42 and try again. So when you change the seat, basically it will change the image. So there's two way to change the image now. We have learned. One is either by changing the seat number or changing the inference steps. So if your inference step is all changed, that is also a good way to change it. So there it goes. Okay, so the new image is generated. We will have a look at it now. Okay, this is not good. Let's increase the inference to 75. Also, you see that now this LoRa is actually using for multiple, people, and that's what we have to be careful with, right? So now that's what I was talking about in painting. So you generate an image, you detect the faces, and then you do in painting. Now in Flux, there might be a easier way to detect the face by stepping into the code and checking when the output came. Somehow you know that this is the face region, that is the face region, and you can apply different models to change the face of different persons in the same image. Technically, that should be possible. I don't know if it is possible right now how to do it. So for that, stick around. There will be a LoRa live stream, and just follow me wherever you are seeing this live stream, and we'll be catching that there. All right, let's continue now. Let's see how this image is. It's the same image. I think beyond certain influence, it changes, doesn't change. Man celebrating in a meeting room. Man celebrating expressively. I don't know what that means, but let's see. Sibly. Also, I'm noticing that. Yeah. Also, I'm not noticing that the spelling is very important in the prompts because I think these Flux models don't do very good job with spell correction. I believe so. That's one thing. If I have to build a product with Flux, I will have to definitely do some spell checks beforehand before the prompt is actually processed. It could be very easy to do it with some vectorization, but that's where we are right now. It's a little bit difficult. Okay, this is much better. There's two of them, but it's fine. We'll just be okay with this. I just want one image for the last, that's all. Okay, so now we have all the images. Let's destroy this runtime. Now we go to a new notebook. This time we will be SVD. Maybe we need SVD or something. I forgot now. Cog Video X, Cog Video X, there's a couple of them like that. Last open September 27 SVD, I think. So Cog Video X was the first plan that we had, but we dropped it because the model was not performing. It was very hard to get it right, but there's another one that I am hearing now is OpenSura. So that's something that I will be also exploring soon. All right, I think this was it. Yeah. You see, do you see? Okay. So yeah, this is what we wanted. We'll start with the model. We'll just start with the images and then animate them as fast as we can, and then we'll hash together the video quickly. Something is wrong with the demos, but I know that this open Sora model is good. Here it is. So I saw that few days time back, and it was nice. We'll definitely be trying it out next time. So most of the time, like here it is talking about how to do it in this system, but Hugging Face doesn't have like I think maybe it has open Sora Hugging Face. Yeah, so they have it here as well, which is interesting. All right, so we have done that. Let's continue quickly. Okay, so this model will take some time to download again. We know that. We have to move it to CUDA, then we have to grant access definitely. We have you need Hugging Face secret token for dealing with this one model, but let's start. So we'll start with the first image, which is this one, download.png. All right, so hopefully we upload it quickly. Yeah, fine. So the model is ready. Move the model to CUDA. Rename this file image.png, and then let's start. Okay, new height and width. Let's see how well the image did. Okay, so it's fine. Torch manual. See generator. Okay, so now we are going to generate it, of course. So I'm just starting with the last parameter that we used. I think the last parameter was very restrictive. So what we have understood is from the last time, noise augmented strength as low as possible, and motion bucket as low as possible. We'll give you a image like video which is with very minimal movement, because you would want the like what I found was if the movement is too much, then the video kind of becomes bad, right? So maybe if the movement is high, we may need more inference, but I don't know this moment. We'll try it now. Alright, so up to 31, 32 frames are done. We will be very soon. Very quickly we'll start. Maybe I'll do another special stream on OpenSora because it looks very impressive. I don't know what is the flow, like what is the like workflow. I think it may have like a way to do it, describe your video. So maybe it is not like image to video, it maybe it's text to video. Okay. So anyways, I'll check this one. Okay, this looks good. Export to video. Let's export it. Let's see the video. So already I can see that the video is distorted a bit. So what we need is more inference, like 150. So if the video gets distorted or you don't see what you expect, then usually that means the model needs more processing. But it could be, I could be completely wrong here. We'll see it soon. All right, still halfway, not even halfway done. So when you increase the inference, this is why I was working with less inference and dealing with noise and motion bucket, because we don't know. Like I did, first of all, I did not know how much more inference. What is the benefit of using more inferences, right? So we'll know it now, hopefully. So what is the dimensions that we are working with? 576. 576 is, I don't know. We'll check. We will check. We will check. So this is when we are using the model to its extreme by pushing the inference this high. But maybe when you are using it for production, it's fine, because again, why not, right? And if everything goes well, next time I'm going to increase the motion bucket and see, maybe increase the noise a bit more and see the output, right? I'll be posting this video also, maybe on all the platforms, YouTube, social, and all the social media platforms. You drop me any question if you have any question, concerns, and things like those. I will be happy to answer. All right, so the inference is done. Let's have a look at the video. What did we get? Okay, I think it's fine. I think it's fine enough. Right, maybe increase the motion bucket just a bit to 50. Noise augmented strength also to 0.4. Pretty high. 0.3 should be all right. But I'm okay with this as well. I can download it. So if the next result we don't like, still we'll push through. New folder, clips. So now this higher motion bucket means that video will be more video like, and also higher noise means the video will be a little bit different, and how much freedom is going to be there for different frames. Maybe noise augment strength you don't want like very high, especially when you're dealing with pictures, right? Because like faces, because you don't want the face to change too much in the like across the frame. But it could work well if you have like a natural scene where the model is free to inference and do whatever it wants to do. So that is the new thing that I have learned now. All right, so I mean we have to wait a bit, but it's not very bad. So we are waiting for this to finish. All right, so oh, it was generated. Okay, so this is with more motion, and I like it. That's good amount of movement, lot of guessing work done. So download this, save it. I'm going to keep the noise low, like 1, and motion bucket too high, like 100. Let's see what do we get. Well, like this is quite good. It's already at this moment. It's good enough for the video that I wanted to do. And we'll after this, I have a feeling that we'll be ready with the next step. So clips, we have saved both clips. So the next one is this one. Download to. So we'll go quickly. So it seems to me that I have figured out how one way of doing it, and that is keep the motion bucket high relatively, and keep the noise low. and inference high, and that gives you good human videos, like in this one, right? And now what we need on top of this is just a little bit of text, which is choose your editor, right? I'm very much comfortable with Premiere Pro, so I will probably be doing it in Premiere Pro. That will be coming in the next stream, of course, and uh, or maybe After Effects. If there is anything simpler, we will have a look at that also. Still, we have like 1 minute to go. Okay, we are getting closer. Half minute. I'm really excited to see this one because now we are going essentially with more than three times the motion that we were initially planning. So I mean, like at half of this current, whatever we are generating, this is already very impressive. So let's see. And next one is OpenSora. I have a little bit of high hopes with OpenSora, but I don't know what is the flow. So will be a good idea, of course. So data processing pipeline. What I don't understand is like it takes a video, takes the text. I have to check really in detail what is OpenSora and how does it work. You can choose different this thing, seed, sampling step, CFG, motion, but image. Hmm. What is this? Video. The video will be displayed on the right panel. Checking the enhanced prompt with GPT-4 to refine the prompt. While the random button will generate a random prompt, then you can choose the resolution, duration, and aspect ratio of the generated video. Besides text, you can also do image. Yeah, this is what I wanted. You can upload an image, then click generate video. Yeah, this is what I will be having a look and seeing how we can, optimize it, because I have a feeling that open source is also going to be good. All right, this is much better. Of course, as we increase the motion, the model has become a little bit cooler, and it's guessing a lot of things nicely based on the environment. It knows. Anyways, it's good. Download. Now this is number 3, probably we'll choose, and then we'll go for this scene number 2. So delete file, and then we will go with scene number 2, which is this one. Let's rename it. Now we'll generate. So with, I don't know, with low inference also is an option I was thinking, but alright. So what happened? Oh, we set the image now already. Just pick the next image, see where how it looks. Okay, so this looks fine as well. Generate. This will take some time. Right, so we are almost done with this. I don't know what we will get out of this, but because I have a feeling that this model can mess up this one, because Stable Diffusion generally is very bad at generating text. But I'm okay even if the text is bad, like, as long as the image is fine, the video is fine, we'll be fine with this. Right, sorry. So video is generated. Excuse me. And we will have a look at the video. So the image is with the too much motion, maybe it's doing a bit of distraction. Fingers are screwed up, like, Stable Diffusion is pretty bad at that. Anyway, so what I'm going to do now is reduce the motion, 30, which is the safer one, and go with something like 50. Just I want to see the preview quickly. Okay, so we'll be stopping the stream in next 10 minutes, and then we'll continue maybe today another stream or maybe tomorrow to finish this work. But yeah, this is where we are right now, and let's see how is this image doing. I thought that the image video generation will go a little bit faster, but maybe I was a little bit wrong. Maybe I was very enthusiastic. And it's okay. I think we will push more time into this. Okay, so again, the model knows something is there, but just just is not able to animate. So when you have your hands and fingers, you have to be very very careful with this. So already there is a bit of a issue with the fingers done by Flux. Usually there are LoRa's that can fix these. Number inference steps 50, noise augmented strength 001. We'll reduce it even more, I would say. Go like 20 or maybe 10, and this also will reduce it to 0.005, so half, and frames are fine. Give it another shot. You give it another shot and see where it goes. All right, let us see. Almost ready, and we can see what how this image is going to do. All right, I'm okay with this. Maybe we'll see next time with Sora and all, but okay. If- because maybe things like this we can probably fix it with be very hard to fix it with LoRa, but we don't know. Maybe. Maybe, should not, because it's all using the base model of stable diffusion, right? So we can definitely do LoRa on top. I think it's possible. We'll check it next time. Right, so we'll generate. The model's ability to influence is pretty good. The Flux model. And Flux AI is also going to, I think the Black Forest AI, they are also going to release a Flux based video model. So really impressed. Really looking forward to that. What they can do. Let us see how's the video. So it looks like the model didn't see the laptop. It's okay. With more inference, maybe we can fix it. This moment, I just want to wrap this up, this video, this live stream. We will definitely evaluate Sora in the next video. Okay. Okay, let's load the image again. Now the image is loaded. Let's see how it looks. Meanwhile, we'll start the generation also. Looks fine. So I'm seeing that this maybe our image cropping could be better because we are losing frames from everywhere. Maybe we should just scale the image a bit down. Or when generating, I think 576 divided by 18 is 72. Okay. So 8 is 72. So we can even just use this to these dimensions to generate the image. In that case, we'll not lose anything. That is also a good option. Correct. Almost close. Excuse me. All right, that's not bad. Little bit space deformation is happening, I feel, but it should be because covered by gun, so it works. All right, so now the last one is this one. All right, image done. Let's process the image. Don't want to do processing next time. What happened? Image what? We need to rename it. Rename file to image.png. Now let's run it again. I mean, like again, we have a hand, so always a bit of risk when you have a hand. So how does OpenSora work? Yes, getting started. Command line inference dot. Okay, so we can just directly inference. Okay, fine. But no, normally we can just run a Gradio app or something. I haven't trained any video model yet, so maybe it will be hard or easy. We don't know. Okay, let's look at this. Okay, fine. Increase the inference to maybe 150. Motion bucket is already very low, and reduce the noise. Maybe we have a frame here. Maybe we can change the. Maybe we can change some things. Don't know. That's also an option of changing the key. Okay, so this might take some time. So, anyways, we'll wait for 2 more minutes and then we'll see where do we go with this. All right, let's have a look at this. Almost close. 25-second more to go. Let's see where we are with this. I, I have a feeling that this video might get acceptable because the way that it did, right? It did a smart thing. It just removed the hand very quickly. You see, this model is very bad at this. And so, you know, maybe with more inference and all, this video might pass. Anyways, we worked on some other things like reduce the noise even more so the face doesn't deform that much. All right, this is bad. This is okay, I think. All right, so we have our videos. we'll stitch them and have it ready in the next video, next live stream. I don't know if I want to do the next live stream on this or maybe something else. So we'll check, and maybe we'll do a quick live stream on this one, like how to join this and how to put text and put a music and upload it on YouTube or somewhere, so you guys can have a look at it, look at the final product. But thanks so much for joining, and if you have any other questions, queries, anything, drop me in comments and follow me and wherever you are seeing me. Thank you so much. Bye.